Hi everyone, welcome to DiffCal Calculus. Today we explore lesson 3.1, the power rule. Number one, the power rule, which stated derivative with respect to x of x to the n is n x n minus 1. Here come the proof. Derivative with respect to x to the n is limit h go to 0, fx plus h minus fx over h. Limit h go to 0, x plus h to the power n minus x to the n over h. Limit h go to 0. We're gonna use binomial theorem to FOIL it out. xn plus n xn minus 1 h plus plus h to the n minus xn. Notice that x to the n cancel out on the top, and on the bottom we have h. Limit h go to 0. Well, we can factor on h from here. Have n xn minus 1 plus, we have a bunch of terms having multiple h. Over h. H and h cancel out. Now we can do a direct sub. And what we have is n xn minus 1 plus all the terms having multiple h gonna be 0 because h go to 0. So the limit gives us n xn minus 1, and that complete the proof of the power rule. The power rule is very useful because we don't have to go through the limit definition to compute derivative of a function. Two properties of derivative. First one is derivative of a constant, that is 0, because slope of a constant function is 0. Derivative of a constant multiplied to the function fx is the same as c multiplied to the derivative of fx, and that is c times f prime x. The derivative of fx plus or minus gx, well, we can separate this out. It's the derivative of fx plus or minus the derivative of gx. Then these are the three properties of derivative. They are very useful to know. Okay, let's take a look at some example. First set of examples, we're going to figure out the derivative of the following expression. Derivative with respect to x up to x squared minus 10x plus 1. And we're going to use the property of derivative. So this way, derivative with respect to x up to x squared minus derivative with respect to x up 10x plus derivative with respect to x up 1. We can take out the number 2, and we have derivative with respect to x of x squared minus 10 derivative with respect to x of x plus derivative of constant is 0. Derivative of x squared, use the power rule. So that would be 2x. Derivative of x, use the power rule, and we have 1. 4x minus 10. Wow, that's cool. In the second example, derivative with respect to x of x squared minus 2 to the power 2. We cannot use the power rule right away. So we got to FOIL it out. And this could be the derivative with respect to x of x squared minus 2 times x squared minus 2. Derivative with respect to x of x to the 4 minus 4x squared plus 4. And this would be derivative of x to the 4th minus 4 derivative of x squared plus derivative of 4. Use the power rule to have 4x to the 3 minus 4 times 2x plus 0. 4x to the 3 minus 8x. Wow, pretty awesome. In C, same thing here. We cannot compute the derivative right away. We can simplify this expression by split this into two fractions. D over dx, x squared over x minus 2 over x. And we have derivative of x minus 2x to the negative 1. Yay! So now we can figure out the derivative of each term. Derivative of x1 by the power rule, and derivative of x to the negative 1 by the power rule is negative 1, x to the negative 2. So this is 1 minus 2 over x squared. Yay! Pretty cool. Yeah. Let's do a few more advanced example. Example, find y prime or f prime x. We have a function fx equal e to the x plus x to the e minus ex plus e squared. So f prime x is gonna be the derivative of each term, e to the x plus derivative of x to the e minus, well, e is a constant multiple, so e derivative of x plus derivative of e squared. Derivative of e to the x from the previous video is e to the x. Derivative of x to the e is a number. We're gonna use the power rule, e x e minus 1. Derivative of x is 1 by the power rule, and the derivative of a constant e squared is just a number, 0. So that gives us e to the x plus e times x e to the negative 1 minus e. Ta-da! Slick. In B, we have 1 over root of 2x. A little tricky, but it shouldn't be too bad. It is 1 over root of 2x is the same as 2x to the power 1 over 2. We can rewrite this as 2x to the negative 1 over 2. And so using exponent rule again, we have 2 to the negative 1 over 2, x to the negative 1 over 2. Yay, meaning that y prime is 2 to the negative 1 over 2 times the derivative of x to the negative 1 over 2. We have a 2 to the negative 1 over 2 multiply to that is negative 1 over 2, x negative 1 over 2 minus 1 is negative 3 over 2. So we can simplify this as 1 over root 2 multiply to negative 1 over 2, and x to the negative 3 over 2 is 1 over x to the 3 over 2. So this would be negative 1 over 2 root 2 x 3 over 2. For application, a PS file is dropped from a bridge. 320 feet above the sea. Its position in feet from the sea water at time t in second is given by ft equal to -16 t squared plus 320. Find the impact velocity. We know velocity is the derivative of the position function f prime t, and that is d over dt of -16 t squared plus 320, where which is -16 d over dt of t squared plus d over dt of 320, and we have -16 times 2t plus 0, -32t. Yay. Impact tells us the time when the PS5 hit sea level. In this case, the sea water. So in order to figure out the time PS5 hit the sea level, we got to set the position function equal to 0. Set position function to 0. Position function is ft equal to 0. -16 t squared plus 320 equal to 0. And then from here we see that t squared is -320 over 16. So t squared is -16 20, and t is root of 20. We don't have negative square root of because time is non-negative. Okay, so once we have the time, that is the time the PS5 hit the sea water. Once we have it, we're gonna sub it in here. Impact velocity is f prime of root 20, and ta-da, -32. Times root of 20, and this would be feet per second. Oh, it's going down pretty fast. Thank you for watching. I hope you found the content useful. See you in the next video.